Hi guys, welcome to my channel. And today we are going to walk through another Leetcode problem, 23, generate parentheses. So given n pairs parentheses, we need to write a function to generate all the combination of well-formed parentheses. So let's say if the input is 3, and that means we have to generate 3 open brackets, open parentheses, also the 3 closed parentheses. And it has to be valid, right? So one open has to be correspond to one close, another open has to correspond to one close. So we cannot have one close and then one open after. So it does not work that way. It has to be well formed. That's what I mean by well formed. So a not well formed will look like something like this. This is not going to be okay. And this is one trivial case. I have only one open and one closed, and this is the only way we can do it. And this question was very popular, asked by so many big names. It's almost 10,000 likes. So let's walk through the algorithm together. And the rule is when open is less or equal to n, we can add open parentheses. When the close, so open means the number of open bracket, close means the number of the amount of the closed bracket is less than or equal to open amount, that we can, and in that case we can add the closed bracket. Let's walk through together for a case where n equals to 2. At the beginning, the open amount equals to 0, the closed amount equals to 0 as well, and then we started with put one open bracket, so open equals to 1, close at equals to 0 at that point, and then we can go two routes. The first route is open equal to 1, and then we add 1 to close. So in that case, is because close, this case is smaller than open, that's why we can add 1 to close, and this is where we are at. And at the same time, because 1 is less than n, that's why we can add 1 more to be as the open, and the close can stay the same. And then at the end, because open is already equal to n, which is 2, we have no choice but adding 1 to the close, and then we can jump into 2 for the close, and this is the end product. Another route would be, after we add 1 to the open, we can add another 1 to the open as well, because n at that point was less than n, which is 2. And now after we added 2, added 1 more to the open, now the open has 2 parentheses and is equal to n, and we cannot add no more. But at this stage, close is still equal to 0, so we can add only the closed parentheses. So we add 1 and add another 1, and that will be the end product for this route. And we will solve this by using backtracking. Let's see how we can do it. So we have a answer list that will collect all the possible answers for strings, and which we will return at the end. And then we have a recursor, because we will recursively call this function. And first, as same as any other recursion function, we have to have an end condition. When, so how can we end it? Is when the number of open is equal to the number of close and is equal to n, and this is the condition where we will terminate the whole thing, and then we will append the given string to the answer, and then we will add either open bracket or close bracket to the given string down below here. And the main algorithm is actually right here. When the number of opens is less than, actually it's less than. When it's equal, we cannot edit no more. When the number of opens is less than the n, which is the maximum we can do, we can keep adding the open parentheses. And also when the number of close is smaller than the number of open, and then we can add the close bracket. So by doing this these two simple conditions, we can ensure that all the combinations are well formed. And we can do exactly that in this recursion function. When the given open, which is the input right here, is less than n, so basically it's less than or equal to n minus 1, which is the same. And then we can call the recursion, and then we can add 1 with the option to add 1 to the open amount. And then we can add the open parentheses to the given string. And the given close will stay the same. That's why we don't add 1 to it. And also in the given string, we don't append the close parentheses to it. So this is one route. The other one, so this corresponds to this one, this guy over here. And the other one can be done in here. When the number of close is smaller than the number of open, we can add 1 to the close amount. At the same time, we can append a close parenthesis to the given string and then pass along to the next statement. To pass along to the next call function of the recursive function. And the starting point to trigger it running will be the given open, the open amount will be started with 1. Also, the close number will be started with 0, because as you can see, all the possible combinations start with open. And this will give us a starting point. So we start at 1 open and 0 close. Also, the starting string will have 1 open parenthesis. And then we can run that. You see, it's pretty efficient. And in terms of time complexity, it's big O of n. Sorry, I mean big of 2 to the power 2n, because each position, it has a choice. Either it has an open or close. And same for the space complexity as well. So that's so much for this solution. I hope you like it. If you do, please like this video and consider subscribing to the channel. That will be a huge encouragement and support to the channel. And thank you so much for watching. I will see you in the next video. Thank you.